How are we doing, everyone? We are out at our Limerick Place high performance SIPs build. We've done our first drop of the scaffold. Roof is on for our top story. Cappings are on. You can see the boys have nailed it. They've done a beautiful negative detail on our Versalux sheeting up here. When you start getting into the details that we do, nothing's really standard or off the shelf. So we kind of have to get creative on what we're going to do to our fascias or our barges and our eave lining. So rather than doing a big metal pressing or a big capping, which would either have lots of swages in it to stop oil canning, or if it was just one full sheet, it's going to oil can and really not look that nice. Seems to be quite common that we're doing on a few of our builds is this negative detail. I quite like it, the clients quite like it, so everyone wins. Now that we've scaffed down, we get on to another part which we really do enjoy, is wrapping our building. It's like wrapping a big Christmas present for our clients really, which they don't get to unwrap, they just move into. For our builds, standard for us is our Pro Climber. These are a vapor permeable WRB, which is a weather resistant barrier. So this is our main protection of the building to stop moisture or water intrusion into our framework and into our structure. It's vapor permeable, so what moisture does get into our structure or is already in there, it allows vapor to transfer through, but water stays out because water and vapor do act differently. So obviously we're cladding this in our NRG, so that is our main water barrier, that's our bulk water, but no doubt at some stage in this building's life, moisture's going to get through it, water's going to get through it, and then this is really our main protection of our building. So we wrap it, tape all the joints, go through and wherever we stapled it, cover up the staple holes. On top of this then, we will do a 70-35 cavity batten, which will run horizontally, and that allows the building to breathe. It allows what vapor does transfer through the envelope. And then it gives us a drainage plane, and it also allows air to rotate through it. So whatever moisture does build up in here can evaporate out. So we'll leave a gap at the top, leave a gap at the bottom. We'll put our cavity closure mesh on it. And yeah, that'll keep this building healthy, mold free, and exactly the day as it is from when we put it in hopefully decades to come. If I'll bring John down this way, you'll get a better idea of our cavity batten system on our roof, which you can see here. So here we've got our cavity batten. This is obviously for our roof membrane now. Again, we use the Pro Climber Mentello wrap, which is for your roof. Vapor permeable WRB again. That's this black stuff that you see. We've then got our cavity batten and then our roof batten. So this cavity batten gives us a drainage plane for whatever moisture builds up in this cavity here to go down and out. And then we use an aluminium mesh as a cavity closer, just to stop bugs and vermin getting into this cavity, but then obviously still let air flow throughout this build-up. That's how we detail our walls and our roofs. Another one, we will take you downstairs to where we've done a couple of our window openings, and we'll show you how we do rough window openings in preparation for windows going in. Cheers. All right, so we are in one of our rough window openings at the moment. Got our Pro Climber dries the bone on. And then this is where our window's gonna sit in here. So what we do is we do a 13mm back dam. So this is just a bit of OSB that we had laying around from the SIPs. That is this back bit, our window frame, UPVC, they're 70mm wide. So that this gap from here to here is 75. Our window frame will sit within here. Once we've got our opening in, we use the Extro Seal, another Pro Climber product. It's a stretchy, flexible tape which molds into our corners and stretches around. And then we fold it over. It's gotten a little bit damaged, so we'll touch this up before we put the window in. And then we do the same with the Extro Seal on the top two corners, and then that keeps our external membrane continuous. And that is what we want, because once our window frame sits within our opening here, we will then tape this membrane to our OSB, which is our internal air barrier, and we will also tape our window frame to the internal air barrier as well, because the inside of our window frame and the inside panel of glass will act as our internal barrier, and then the outside of the window frame and the glass will act as our external WRB. With all of our windows, we have them set within our panel because we need our insulation layer to be continuous, and a window is part of our insulation layer. So we want, and the glass of the window is the insulation layer as well as the frame. So we want our glass sitting within our wall framing, not sitting proud and out. Otherwise we will have a break in our thermal envelope through this joint in the frame. So we will have them all set within here, and that will keep the thermal envelope, the external envelope continuous, and should allow for a very well performing building. We'll bring you inside now as well, because we have started running some of our HRV system, which is the lungs of this building. All right, so we are inside the kitchen, living, dining area now at the moment, and as you can see, we have started our rough-ins on our HRV system and also our electrical. The HRV are the 90mm white piping that you can see. That is the lungs of our building effectively. Because we're building this house so well and so tight, it then relies on continuous mechanical ventilation to keep the air inside the building fresh and healthy. In a standard built home in Perth, you're relying on it being a windy day, opening your windows, and the house being very leaky and just general air and convection coming in all the gaps and holes inside the envelope or around the envelope of your house, which is just going to be not good for you. It's going to be dusty, it could carry mold, pollen, everything else, you name it. So this we have in the kitchen area, in the laundry, and in the wet areas. We have exhausts, which exhaust the dirty, stale air. And then in all the living rooms, we've got the fresh air outlets. So this system will run 24/7, 365 days a year, doesn't stop, it's extremely efficient. And it also runs a heat exchange unit, which if we can get this to around the 1 air changes at ACH 50, they run at 98% efficiency in terms of mixing that, not mixing, but changing the temperature off from the internal to the external so that you're not wasting your energy cooling or heating your house and then just shooting it to the outside. It pre-tempers it to bring it in, but we'll give you more detail on that once we actually put the unit in. Also built into that is filters. So the fresh air is filtered fresh air from outside, pulls any pollens, any pollutants, anything like that from the air before it comes into your house. So it's very good for people that suffer allergies or just susceptible to bad air quality. But yeah, we'll take you into where the unit is actually going to go, and we'll show you how many pipes we've had to try and fit within this framework. All right, so as you can see above me, these are where all of our piping for our HRV unit are leading to. We have a storeroom above us, which we are using as a dedicated HRV mechanical room. We're going to put the switchboard in there as well. But yeah, so we've got eight in, 8 out. So we've got 16 pipes in total. 8 going through the inlet hole, 8 going through the exhaust hole. These run into 2 separate plenums, which then run into our Zender HRV unit, which John will be out for when we put that in. But yeah, bit of fun trying to get these through, but we got there. Yeah, we'll bring you back for the install.